the continuation of the session as we are discussing the questions related to measuring length. What could be the right answer for this question? For which one of the following measurement would a micrometer screw gauge be most suitable? If you want to use a micrometer screw gauge, which one is the most suitable? So the correct answer is C, because length of the page or length of the pencil, it will be too long compared to the size or the jaws of the micrometer. Diameter of the wire is the most suitable one. Diameter of atom is very small. Even a micrometer cannot measure that small value. The diagram shows a measuring device. For which measurement this device is suitable? A, B, C or D? When you check the values, diameter of cylinder of aluminium about 20 centimeter, if you multiply by 10, it will be 200 millimeter. That's too low, too big. 200 millimeter for this, so that's not the right. The distance between two molecules, that will be very small. It cannot measure the distance between atom or molecule. Length of rod of iron, 1 meter. That's too long, like 1 meter. How I can place 1 meter length of this iron rod between the jaws? So that's also not correct. But the thickness of sheet of copper, which is about 1.5 millimeters, so D is the right answer for this. Another question. Micrometer screw gauge reads 0.02 when the jaws are fully closed. So there is some value or there is a zero error which is 0.02. It reads 0.56 when the measuring the diameter of a metal wire. What is the diameter of the metal wire? So 0.02 reading was there when nothing was placed. And then we place a metal wire and measuring its diameter, it is coming out as 0.56. So what could be the right answer and what is the diameter of the wire? Already there is a reading of 0.02 and we place a wire with an, like there's an error of 0.02 and we place a wire, then it is the reading was coming out 0.56. So what is the actual reading or diameter? So the correct answer is B. Why correct answer is B? Because this is the error. So extra reading is already there. The error is there 0.02. When we place, this is a reading with error 0.56. So when how to get the diameter? So it will be 0.56 minus the error, which is 0.02. So it will come out as 0.54 or B is the right answer. Now the structure questions. Another student provided with the mean of cutting of sheet and decide to find the average thickness using a single measuring instrument. Assume that the surface of sheets are perfectly smooth. Name a measuring instrument she could use. So what student could use to measure the thickness of the sheet as accurately as possible? So she can use a micrometer. Then, yeah, the micrometer is the answer. Then how she can describe the procedure she should follow to obtain the accurate value of the average thickness of the sheet. And details of how to read the instrument is not required. Like you don't have to mention read the main scale or circular scale. You just have to mention that how it can be used. So what student can use, first thing, whenever a micrometer is used, so we should always check for zero error. That should be our first point. Then instead of measuring for one sheet, because one sheet it will be very thin, so when you are reading a small value, your error or percentage error is higher as compared to a large value. What she can do, then measure, like place 100 sheets between the jaws of micrometer and record the reading. But we don't have to mention how the readings are taken. We just have to mention the experimental procedure. So place 100 sheets between the jaws of micrometer and record the reading. After placing 100 sheet and recording the reading, but we need for one. So what we should do, divide the thickness recorded by number of sheets to find thickness of one sheet. Then what else can be done for experimental accuracy? Then repeat the procedure from different position and avoid parallax error. For your reference, I here you can find, I mentioned answer here, but this does not mean you have to just copy and paste. It's like you write your answer in your own word and check whether you include those points. You don't understand point 2 and point 3. What is the meaning of point 2? Look, you have sheets. So instead of recording a thickness of one sheet, because the thickness of one sheet is very small, so it will not be accurate because very small reading is there. So to improve this, what you do or what you did, you will record the thickness for like 100 sheets or 10 sheets, so that the value which you will read, it will be higher value. So we'll record the thickness for 100 sheets, like we place a micrometer and record the thickness for 100 sheets. And to get the thickness for one sheet, like example, the thick, if in numbers, if I say the thickness for 100 sheets was, yeah, we want to measure one, but because if we directly place a one sheet, it won't be accurate. Why it won't be accurate? Because the value will be very small, and small values, when you are reading a small values, there are chances that you get an error. So to improve the experimental accuracy, you record the thickness for 100 sheet. Example, the thickness for 100 sheet was 200 millimeter, but you need for one. So how to get the thickness for one sheet? The thickness for 100 divided by the total number of sheets. The total number was 100. So 200 divided by 100. So I'll get the thickness for one sheet. So the main purpose for this second point is to improve the experimental accuracy, because measuring thickness for one will be very small and it may lead to an error. But when we record the thickness for 100 sheets, It's a large value, so it will reduce the chance of error. If I say, like example, if you want to read 0.1 centimeter and you want to read 7.2 centimeter, in which measurement you are likely to make an error? You're likely to make an error in a very small measurement. Large measurement are easy to record. That's why we always prefer to measure large values. Is it clear? Yes, Abdullah. Any doubt in this question? Is it clear to everyone? Another question: why do repeat experiment from different position? Why we are repeating the experiment from different position? Basically, maybe the thickness is not a uniform thickness. Like some parts a sheet is thick, some parts the sheet is thin. So to get an average, for example, this part the sheets are thicker, this part maybe they are thinner. So just to get an average thickness, we are repeating the experiment from different positions. Okay, another question. Figure shows a part of a measuring instrument. State the name of this instrument. What we call this instrument? What is the name of this measuring instrument? So it's a micrometer screw gauge. Then record the reading shown in figure. So how we record the reading? The formula yesterday I told, if you want to read the micrometer, the reading on the micrometer is equals to main scale reading plus the circular scale multiplied by 0.01 millimeter. So what is the main scale reading here? This is the main scale. What is the main scale reading? I'm writing in short main scale as MS. What is the main scale reading here? Main scale is the last point which is visible. So 0, 0.5, 1, 0, 0.51, 1.52, 2.5. So main scale is 2.5. Now what about the circular scale reading? Which line is coinciding with the circular scale? This is 20, 21, 22 and 23. For circular scale, it is like a whole number, like the number of the line. It's not in points, it's directly in number. So it will be 23. Multiplied by 0.01. First, always do multiplication. Like if you in maths, you have studied like BOD mass, bracket of division, multiplication, addition, subtraction. It means you should do first division, then multiplication, then addition, and at the last subtraction. So first we should do division, but there is no division. Then we should do multiplication. So 23 multiplied by 0.01. So that will come out as 0.23. And this is 2.5. So 2.5 plus 0.23. 2.5 plus, this is not multiplication, it's addition. 2.5 is added to 0.23. What is the final answer? 2.5 plus 0.23. It's 2.5 plus 0.23. So simply when you add them, 2.5 plus 0.23, it will come out as 2.73 millimeter. So the correct answer for B is 2.73, and you can see the answers. It is 2.73. Then again a similar question. Describe how would you find the thickness of sheet of paper used in a magazine. So how we can find a thickness of paper which are used in a magazine. So first thing, whenever you are using a micrometer, what you should do, you should check for zero error. That is first thing. Then place like 50 sheets or 100 sheets between the jaws of micrometer, and record the value. Then divide the thickness recorded by number of sheets. Then we will repeat the experiment. With different positions. On sheet. Then avoid parallax error. And because it is a paper, so you should not close it too tightly, otherwise it will deform the paper. So these are the points which you will include. It's a similar answer what we have discussed, but in the last answer I did not mention do not close too tightly, because in the last answer it was a metal sheet. Metal sheet, not we are not able to deform them easily, so their thickness will not change too much. But in case of paper, which is a soft material, can easily deform. That's why we should not close it too tightly. Is it clear to everyone? Your response is important, because from your response I have an idea that whether you are understanding the topic. If you have any question or doubt, or you want me to repeat any answer, you can just mention in a chat or use your mic. Then next topic, because the main topic is length and time, so we have discussed about the length, but now it's about time. So to measure a time, we can use different instrument apparatus. We can use light gates. How light gates are used, you're not studying that in your course. Mainly you will use the stopwatches or stop clocks instead of these light gates and electronic timers. So example, if we want to measure a time period of a pendulum, what is the meaning of a time period of a pendulum? Like if I label the position, this is position A, the center is position B, and this is position C. So when this pendulum is vibrating from A to B and then B to C, so when it is going from A to B and then from B to C and from C, it returned back to B and then to A. So going from A to B and then to C and returning back, that is called one oscillation or one vibration. So moving, in this example, moving from A to C and return back, this is known as one oscillation, or you can also say vibration. So, and there are positions as well, like we call the position A and C are known as extreme position, or maximum position, where B is called mean position or the center position. So because, why it is called A and C are called extreme position? Because that is the maximum distance which this pendulum can move. And what is a simple pendulum? A simple pendulum means when a mass is attached with a string and it is vibrating, we call that as a pendulum. This sphere, this sphere is called a bob. It's a name given to this sphere. So when any mass attached with a wire and that mass is vibrating and attached with a wire and it is continuously vibrating to and fro, we call that as a pendulum. And this motion is known as a vibratory motion or oscillation. So what is the time period? The time period is the time taken by this pendulum to move from one position to another and then return back. So like example, we release the pendulum from A, it will move to B, and then from B it will go to C and return back. So that is known as, the time interval is known as time period. So definition of the time period, it is the time to complete one oscillation. So how much time it will take to complete one oscillation or vibration, we call that time as a time period. In your course outline, you have an experiment to find the time period of the pendulum. So how we can find the time period of the pendulum experimentally? So finding the time period of simple pendulum. Yet the term oscillation means vibration, or when you start to and fro motion. When you start your motion, you move to one place and then you return back to your same place. That is called one oscillation or one vibration. And vibratory motion is always a repeated motion, like object will continue to move in this manner until it will lose its energy and stop at mean position. So finding the time period of pendulum, experimentally how we can find the time period of a pendulum. So example, this is a string or a wire, and you attach a metal sphere which is called a bob. So first point, what are the points? Number one, we will mark the mean position. And normally we use a stopwatch, so we should reset the stopwatch. Maybe the stopwatch was used for another experiment previously, so it may have that time interval. So first thing, we should reset the stopwatch. Then what we do, we will mark the mean position. So on a pendulum, like we know this position, so on the ground we can mark this as a mean position. Then we will move the pendulum to extreme position and mark that point. So what we will do, we will move this pendulum to another position. We call that as extreme position. And we will mark that point as well. Because where we'll mark not in air, we'll mark these points, mean and extreme points, on the ground. On the base we will mark those. So this is like extreme position. Then what will be the fourth point? We will release the pendulum from extreme position and start the stopwatch. So the moment we release this pendulum, we'll have this stopwatch so we'll start the timer the moment we release. Like example, originally it will be 0, but the moment we release, we will press this button to start. And then what happen, it will go to other side and it will return. But again, this will be a very short time interval, so it will not be accurate. So what we do for increasing the experimental accuracy, or to get the more accurate result, we will record the time for 10 vibration. It can be any number, like I am doing for 10, you can do for 20 or 15. So record the time for 10 vibration and you call that time as small t. Then to find the time period, the time period t is equals to time for vibration divided by number of vibrations. By example, time for vibration, say it was 15 or 30, divide by number of vibration, we will get the time period. And again, then repeat the experiment to improve experimental accuracy. Is it clear, this experiment, how to find the time period of a simple pendulum? So we release the pendulum from extreme position, it will move from one side to another extreme and then it will return back. And this will, like example, if this highlighted part is representing a pendulum, we release from here, so it will go and then return. This is one vibration, then go and return, second, third, fourth, fifth, sixth, seven, 8, 9 and 10. So example, the time for 10 vibration was 15 seconds, but we need the time period. So the total time which we record divide by number of vibration. Here we took 10 vibration, so 15 divided by 10, it will come out as 1.5 second. Yes, Abdullah Sarfraz, you are having a question.
Yes, sir. After one vibration, the bob will lose some energy, so it
Yeah,
will
Bob
not
will lose some
make.
energy. That's right, Abdullah. But not too much in 10 vibration, because the experiment is so fast. In a 10 vibration, yes, there will be some loss of energy, but not too much. But like example, if you say I'm recording for time for more accuracy, I'm recording for 500 vibration. That will be wrong, because before completing a 500 vibration, the Bob might stop. So 10 is a very small number in that sense that it does not lose most of its energy and still it is continue to move. Is it clear?
Yes, sir.
Anyone having a doubt in this part or a question? Any question or a doubt related to this experiment? So example, a pendulum is making 50 complete swings in 2 minutes and 40 seconds. What is the time period? So how you can work out a time period? So if a pendulum is making 50 complete swings, so 50 vibration in 2 minutes and 40 seconds, but all the answers are in second, so we have to convert this 2 minutes and 40 seconds into second. So what will be total number of seconds in 2 minutes and 40 seconds? In 2 minutes we have 120, and 120 plus, no, you don't have to multiply anything. It is 2 minutes and 40 seconds. 2 minutes. How many seconds are there? 1 minute is having 60 seconds. So 2 minutes. So it will be 120. And because 2 minutes and 40 seconds, so 120 plus 40. So total number of seconds here, it will be 160. So you will have total 160 seconds. So total 160 seconds are there in 2 minutes and 40 seconds. And the vibration are 50, but you're finding for one. So the time interval divided by number of vibration. So the time interval was 160 and the number of vibration are 50. So 160 divided by 50, you will get as 3.2. So B will be the right answer. Is it clear, this example, to everyone? This is a test question. You can do it later. Now I will discuss the structure question. That's the last part. In this question, a student times a single oscillation or single vibration with a stopwatch in 10 separate measurements. Like student measure a time for single vibration or one oscillation. He's getting different answer: 1.8, 1.9, 1.7, 1.9, 1.8, 1.8, 1.9, 1.7, 1.8, 1.8. What is the best value obtainable from these readings? What could be the best answer here? Like student is getting different answer, but you can see one of the answer is repeated many times. So what is the best value here? The best value for this experiment. So best value for this experiment is 1.8. And what is the reason? because it repeat many times, or when you find the average, you will find 1.8 will be average. The second part, describe how would you use a stopwatch. The student describe how using the same stopwatch student can find the period of oscillation more accurately. So basically how he can find the time period. So the same steps are there. Reset the stopwatch. So the similar answer, I'll copy from the previous one like this. So similar answer, reset the stopwatch, mark the mean position, move the pendulum to extreme and mark that point, release the pendulum from extreme position and start the stopwatch, then record the time for 10 vibration, then divide the time to find the time period, divide the time with the number of vibration and repeat the experiment with, so to improve the experimental accuracy. Yes, Abdullah?
So can't we just write like repeat the experiment more times?
Yeah, repeat the experiment, you can mention that. Here it's written repeat several times or repeat or find a mean. That's okay. Even you mention repeat, you mention do it several times. These are the answer references there. It's just like you should include your answer should have these points. Not exactly same word, but same idea should be there.
So still I have to write this.
Here. No, you can write just repeat the experiment. That's okay. So this is the last part. Is it clear? The topic 1.1, length and the time. Anyone having a question or a doubt? So the topic 1.1, we conclude topic 1.1, which is about length and time.